When we are looking at solutions, we also want to know how stable is our solution. We want to find out what will happen if some parameters change. Now, let's suppose that we have a good system, that we have determined everything properly, and we find out the reason how to deal with it, and it really corresponds with the actual situation. Applying this with the right numbers, we can say that we found an optimal solution. But what would happen when some of the parameters would change? How will the changes of the parameters affect the solution? We call this the elasticity of the system. Another parameter that can happen, or another thing that can happen, is when we change the parameters. Can we find a better solution? Can we find something better even though we have an optimal solution? Can we change something and find out a better solution than the one we had? All these elements will be covered in the course. We will be looking into these elements, the elasticity, the relaxation of the solution, and try to find better ways to use our means. That's the goal. We want to find a solution that will optimize the work we are doing. When I talk about the precision of the calculation, it's also very important to go a little bit back in history. When you see those old buildings, when you see some fantastic constructions, look at the Eiffel Tower, look at some old buildings that were made before people had computers. People were using different tools. I remember that my father showed me a calculation ruler. It's kind of a ruler system where you can do logarithms, you can do multiplications, you can do all kinds of operations, and they were using this to do all the calculation. Now you can imagine that the precision of those tools is very limited. And that's also the reason why in those days people put a lot of security parameters on the calculations they did. Now, today, we have calculators, even in our phone. We have spreadsheet programs, we have special calculation programs, and those programs can provide a large number of decimals. We can ask ourselves, when Excel provides 20 decimals, if these decimals all have the same value. And it's a very important thing to think about, because remember, in high school or college, your teacher may have told you how many decimals to use. But what if nobody tells you? Nobody tells you how many decimals you need. Now, basically, this is a problem, because people expect that me as a teacher, I will tell you how many decimals you will have to calculate to get a good result. But you have to find it out yourself. You have to understand how many decimals. Of course, we have certain situations where we can use logic to see what we have. But on the other hand, we also have to be careful that we are looking at the right number of decimals that we have to maintain in our calculations. An element, what I want to introduce here, is what we call significant numbers. And significant numbers is in fact a concept which relates to the value of the numbers we have. How many numbers are significant, have a value? How many decimals can we accept? Is it 1 decimal, no decimals, 100 decimals? We have to look into these things, how we deal with those numbers. And let's look at the ruler below. And we want to measure the length of this piece of wood. How much you would say it is? Will it be 14 centimeters? Will it be 14.2, 14.3, 14.35? What will be the length? Now here is the discussion what we will talk about in the next slide, and this is about significant numbers. I know 14 is correct. I know that at least the piece of wood or the piece that I'm measuring is 14 centimeters long. I'm also sure that it's at least 14.2 centimeters. But what do I hear? Where do I get the 0.2 from? Well, when I look at the green line, I can say it's a little bit closer to 2 than to 3. So basically here I will say 14.2. Now what's the value of the 0.2? Is that a real, let's say, a number with absolute value? I know 14 is absolutely true, but the 2 I gained by estimation, by reasoning that the end of this line is a little bit closer to the 0.2 than to the 0.3. That last number has a little bit lower value than the 14, but we can reason, we can say it is correct because we see that this is a little bit closer. Now, the fact that we're using more or less decimals, that depends on the measuring tool that we are using. A micrometer can measure up to a micron. All kinds of measuring equipment may have their own limitations. When you go and take petrol, you can see what the numbers are. You can have the same estimation like we did here. Now let's look at the definition of the significant numbers. When we want to determine the number of significant numbers of a number, we have to look at the following step. First of all, we have to find the first number that is different from 0. So in our measurement, it's the number 1, the one from the 14.2 that we estimated. The second step is to find the last significant number. And this is the last number which is obtained by reasoning. It is 14.2. So 2 is the last significant number. And in this number 14.2, we can say that the number has 3 significant numbers. Now, whenever we write a number, the numbers that we write down on the paper should only be the significant numbers. If I put 14.20, well, that 0 or 2 has no value because I cannot measure it. Now, the last number, like I said before, is in fact a number which has some uncertainty. We are not really sure about the exactliness of the 2. We can have something like 14.1, which is closer to 2. It would also be 14.2. So basically what we have here is a number, is a length, which I can say is between 14.15 and 14.24. So this number is between. If it would be over 2.5, we would say 14.3. So the last number is a number which contains uncertainty, but we can find it by reasoning. The result, of course, depends on the precision of the measuring device. And we should relate to what is possible. I always had a very good example when I was teaching in the aviation school. The pilots had to track or had to calculate the heading to fly from point A to B. Now, they had to take into account the wind, and based on the wind, they have to select the heading so that they would fly from A and arrive in B. Now, when they calculated this, you look at the compass in the cockpit, and that's the compass they're using, or even a gyro compass, it's not a big difference. And they calculated something like 35 degrees, 24 minutes, and 37.5 arc seconds. The calculation was perfectly correct, but they failed their flight. Why did they fail their flight? Well, it is impossible to fly that heading because we only have markings for about 5 degrees. So when you make a calculation and when you have a result, that result should be applicable with the tools that you have. If you ask somebody to get you 35.732 liters of petrol, it will not be possible unless you have a device that can measure it. When you go to the gas station, this will not be possible. So basically, that's the thing I want to say here, that you have to be careful about all the numbers you give to somebody else when you're talking about numbers, when you want to have a specific result. And we will talk about that while we are doing our different tools that we will be using as part of quantitative methods. The last presentation of this video is to look at some special issues where we have the decimals of numbers. First of all, we have to say it has no sense to provide more decimals than the significant number has. So when we have the 14.2, giving more decimals has no sense at all. When we want to measure a piece of the material, we should measure it using the precision of the measuring equipment. In our case, a ruler with a precision of 1 millimeter. We may have rulers which have more precisions, where the precision is higher. But in our case, we had 1 millimeter. When I want to have 1/3 of a piece of 1 meter, I want to have 33.3 centimeters, 33 centimeters and 3 millimeters. I cannot measure the second 3 or the third 3 with the standard ruler that I have. The same thing, like I said at the gas station, we should take into account the precision of the counting mechanism on the volume indication that we have on this system at the gas station. Now, another thing is a little bit funny, and what can we say about the significant numbers of, for example, 5 cars? I have 5 cars. How many significant numbers do we have? We defined the significant numbers. We start with the first number different from 0. This is 5. And then we look until we reach the last number which is obtained by estimation, by evaluation. And well, people would say this as one significant number. Let's say 15 cars. We have 2 significant numbers. But is that true? Can I say with 100% certainty that I have 5.0 cars? What do you think? Can I say with certainty that I have 5.000 cars? Since we have a car, it's a car or it's no car. 4.99 cars doesn't exist. We can not have 5.3 cars. If we have 0.3 parts of a car, we can call it a wreck. So basically, we can continue putting their zeros up to infinity. And when we have natural numbers, like cars, the counting numbers, their significance is unlimited. We have an infinite number of significant numbers. So all the zeros I put behind the 5, they are all significant. So that's a very special case, but in most cases we will see when we measure that we have to limit the decimals to a certain level that corresponds with the tools we've been using. First of all, if we use a tool measuring millimeters at most, we cannot use the results to measuring microns. That's not possible. On the other hand, when we have a result, we have to see what measuring equipment are we using to measure that value. Now, this was the things I wanted to say as a start of quantitative methods, operations research. Now we will be going to the next sessions, and in the next session we will look at the advantages and the approach to quantitative methods. This is a first video. We're starting the course. There are a lot of things to come, But you already did a great job because it was a long presentation, and I'm looking forward to seeing you in the next video. Thank you and bye bye.